With quantitative data, we want to be able to do the same thing as we did with categorical data, right? We want to make a frequency distribution and then calculate the relative frequency and then the percent frequency, and then also maybe graph the frequency distribution as well. Okay. Now, the only difference here is that the categories or the classes are not preset. Right? The data will come into a form like this. It's a bunch of numbers. And so we need to do one extra step. Right? We need to make the classes ourselves in order to put each observation into one of the class. Okay. Now, there will be three steps in this process. First one is determine the number of non-overlapping class, right? It has to be non-overlapping because we can't have any observation double count, right? Each observation can only go into each class once. Okay, so all right, so that's the criteria. Now, a couple rules, quote unquote rules, right? That it's just good habits to do. The each class have to be the same width, all right? And okay, each class is the same width, and then also the number of class, it's up to you, okay, of the data scientist, right? Because after all, right, you are creating a table, you are creating a graph to represent this data. Okay, so it's really up to you. Now as you will see, it become obvious. The more number of classes that you have, right? The more classes, right? The better the shape. All right, better the shape. I'll give you an extreme example. Suppose that you just have one class, meaning that you put every single observation, right, in that one class, right? So basically, you have the class go from 0 to let's say we're going to label the class 0 to 200. All right, so everything will be there. Then what does this frequency distribution look like? 50. Right? Every observation is in this one class. Right? This tells us nothing. This doesn't give us any information at all. Okay, so first we just have to pick a class, pick a number. Generally speaking, 6 works pretty well. You see that in the textbooks, they have some rule. Right? So, for example, some textbooks might use this rule. Either you take the cube root of n, or you can take the square root of n. So in this case, right, if you take 50, so n here equals 50. If you take the cube root of n, right, cube root of n, you're going to get 3.68. So that's about four number of classes. If you take the square root of n, you get 7.07. So that's about 7 classes, right? 4 to 7. Any of those will be fine. Again, more class the more class you use, the better the shape. Right? Now you don't want too many class either, right? So if you look at the extreme, right? You can have every observation as one class, but then that's too much information that doesn't tell you much there by itself. So how about this? Let's take 6 classes. Okay, as our let's pick 6 classes as our number. Okay. Right, and then okay, so once you use 6, okay, this is your choose, right? This is your choice. Right? This is your choice. And then so once you choose 6, then to determine the width, right, you will simply take, you do this formula. So for width, it will equal the maximum number minus the minimum number divided by 6, the number of classes. Okay? All right. Okay, so in this case, we just have to look at our data set and see what's the max and what's the min. So we just take a look here, and unfortunately, this is not in order, so we just hunt it around a little bit, and boom, okay, 109, that's our maximum. Minimum is going to be 52, okay, divided by 6, right? And this is equal to 9.5, okay? Now, you want to give yourself a little freedom to make the math work out for you. So I'm just going to round up and say that this is 10. Okay, so the width of each class, I want to say that it is 10. Okay, and then now Once I have the class, right, I want to determine the class limit, because for every observation, I want to know which class do I put it in. Okay, so here we go. Here are class. I'm gonna draw a line here. Okay, and you just have to make sure your width is 10. Now my minimum number is 52. Okay, and here you have a lot of freedom. Right? It's up to you. You just have to make it look nice, make the table look nice. So I'm going to choose then go from 50 to 59. That is a class width of 10. So any number between 50 and 59, I will put it in the first class. Next class, right, 60 through 69. Okay, I don't have to worry about decimals because I look at my data and there's no decimals here. Okay, so I make it very clear every time I look at an observation which class to put it in. Now, compared to a bar chart that we did for categorical data, remember there's a gap in here. There's nothing in between, right? Here, right, when we graph it, right, what you're going to see is that we're going to be touching each other. Each of these classes will be touching each other because this is continuous. Going from 59 to 60, right, will be continuous. Okay, so keep that in mind. Let's just keep going. 70, 79. 109. Oh, wait a minute. Okay, boom. That's it. I have my that's my maximum number, so I don't need to create another class, right? If I do create another class, let's say 110 to 119, there'll be nothing in there, right? Okay, now once I have the class, here we go, right? Here's my frequency. And look, I have my number. Oh, by the way, before I do that, let me count my number of classes. 1, 2, 3, 4, 5, 6. I have my 6 classes. Okay, let me count the frequency. And so all you do is, right, you just take each observation and then you say, okay, for example, 91, cross that out. 91 goes in here. Okay, 91 goes into this box here, so I'm going to count that as 1, and then you just count away. You just count away here. Okay, so feel free to pause the video, go ahead and give it a count, cross each one out as you go, and then check your answer here. Okay, so I just do a little tick marks to help myself count, and then now I can write it down, the numbers. Okay, if you did this all right, at the bottom here, you should get 50, right? And that should be the total number of sample size. Now, once you have the frequency distribution, then everything else is going to look and behave just like we did with the categorical data, because now that step is over, right? And we have all the classes and we have the frequency that we constructed. All right, so let's very quickly, we can do a relative frequency and a percent frequency. Okay, and remember the easiest way to do this is simply add another column right next to it. Okay, so I'll just write it down and you can pause the video and check your answer here when you're done. Okay, so remember how to calculate relative frequency. It is just the frequency divided by the sample size. All right, so for the first one, it would be 2 divided by 50. So 2 divided by 50, it will be 0.04. Okay, and then to get the percent frequency, all you got to do is just multiply the relative frequency by 100 and you get that. Right? And this is expressed in percentage, and this is expressed in proportion. Okay, and then just always remember to double check your work. If you add this together, you should get 1 if you did it correctly, and if you did this correctly, when you add up together, you should get 100. right, for 100%. All right, now with categorical data, we did a bar chart, right? A bar or a bar graph, right? So that's the bar. There's a bar graph, a bar chart over here, and it's simply a graphical representation of the frequency distribution. Okay. Now with quantitative data, right? We just simply don't call it a bar chart. We call it a histogram. Right? So with quantitative data, we always call it a histogram. Okay, and now with bar chart, right, so one more note here. With bar chart is you can actually, as an option, if you like, you can put the classes on the vertical axis. So you can basically shift it, twist it 90 degrees like this, and then just have the classes on the vertical axis if you like. Right? With quantitative data, meaning with a histogram, right, you don't do that. You always put the variable of interest, put the classes in the horizontal axis. Okay, and this is typically done because again the data are continuous. Right. Okay, so we're gonna do it like that. Okay, so here let me go ahead and draw in the lines. All right, so I have my axes drawn. Right here, so here's gonna be my data point. Okay, and now I don't have to write class because these numbers actually have a meaning. So when I label my axes, I have the option of just labeling as the cost. So here on the bottom here is going to be the cost. All right, cost in terms of money. Here, I can label that. You can write class if you like. That also work. All right, now. There are no separations because my numbers are continuous. So here's one thing you can do. What we want to illustrate is the limits of the class. Okay, so I'm going to make these tick marks as evenly as possible. Okay, and evenly as possible is important because each class is the same width numerically. So here we go. 1, 2, 3, 4, 5, 6. Right? So here is 50, 60, 70, 80, 90, 100. Oh, and I need to go one more. 110. Okay, and also this will give me my class width. Now I can count over here, and the highest frequency is 16. So I'm going to go ahead and make tick marks going all the way up to 16. Okay, so I went ahead and added these tick marks. Then, of course, if we have graph paper, this will be a lot easier, right? Okay, and then just go ahead and make mark 5, 10, and 15. That's good enough for us. Oh, one note here. Now, by default, when we graph, okay, we typically always starts at 0, 0. Okay, now on the vertical here, I do have 0 and going up. Now here, I'm starting at 0, but I'm jumping all the way to 50. Okay, now this is for visual purposes, right? Obviously, if my data point starts at 50, if I actually make it to scale, my graph will be pushed all the way over to the right. Okay, that's not going to look good. But then, but I don't want to mislead people, right, who read this graph. So what I'm going to do is I'm going to draw a break in between the line, right? So once I draw that break there. Once I draw that break there, what that tells the reader is that this is not to scale. So there's a truncation going on here, and we're jumping from 0 to, and starting point is at 50. Okay, and at this point, I have the graph set up, and now I just have to fill in the frequency and build my histogram. So I'll go ahead and do 2 for the first class. First class 2, second class 13. Second class 13, the third class 16. Okay, and so on. Go ahead and pause and give it a try. Check answer here later. All right, once you have all the lines drawn, remember, right, these are non-overlapping, but there is no separation between the class because we want to represent this as continuous data set, right? So there's nothing left. These numbers are right next to each other, okay? And simply just draw it down, and voila, okay? And there you go, and that is our histogram. Okay, one last thing that we're going to do with the frequency distribution table, right, is the idea of cumulative frequency. Okay, so to begin this, let's go ahead. I have a large table here on the bottom here. Let's go ahead and fill in these two columns first. Okay, and we're just going to fill them in using the information above. This is the same data set, right? And we already have these two. Okay, so go ahead and just go ahead and fill them in. All right, now that we have them filled in, right, cumulative idea is very simple. We're starting from the lowest number or the lowest class, and the cumulative idea, so we have cumulative frequency, cumulative relative frequency, and cumulative percentage, is just adding up everything before it, or adding up that class and everything before it. All right, so we'll start with cumulative frequency, and I think it will become clear. So cumulative frequency, because this is the first class, then cumulatively, there is only 2 observations that has happened. So that's 2. Now, then to get the cumulative frequency for the next class, all we have to do is just take the new frequency. So there's 13 observations in this class now, plus the 2 that was in there before. Now we have 15. Okay, and then the next cumulative frequency for the next class will be 15 plus 16. All right, so that'll be 31, and then you add, and then you add the 7. So now we get 38. Add the 7 again. All right, add the 7 again. We get 45, and then add the 5. We get 5. All right. Now, if you did it correctly, then you get 50. Add the 5. 45 plus 5 is 50. And if you did it correctly, the last number for under the cumulative frequency column should be the total number of observations, the total number of sample size. Right? And what you do here, right? What the purpose of the cumulative frequency is at any point now, where, so for example, I look at this class, right, 80 to 89, right? Then I have a number here, 38. Now, what does this tell me? This tells me that there are 38 observations below, right, 90. Okay, so you look at here, right, 38 observations below 90, less than 90. Right, or it is 89 or below. Okay, we can say it like that. Right, there are 31 observations, 79 and below. Okay, so value at 79 and below. Okay, it's just additional information, additional summarization that allows us to make a different type of statement. Okay, cumulative relative frequency works the same way. Right, the first class. Right, there's nothing else before it, so just 0.04. To get the next cumulative, I'm accumulating all my relative frequencies. So here, I'm just going to add the 0.26. So I get 0.30, 0.30 plus 0.32, 0.62, and so on. So I'm going to go ahead and just do the math for the rest here, and I will do the same thing for the cumulative percent frequency. You can pause and check your work when you're done. All right, okay. So, and then if you did it right, the cumulative relative frequency, if you simply, again, we're just adding up the next class. So here, 0.62, then to get to the next one, you add 0.14, you get that. And if you did it correctly, at the end, you should get 1, because accumulating all of the relative frequency, the total is 1. With percent, right, that's going to look very similar. I'm just going to keep adding a crossover, and when you add up, when you're done at the end, the last one here should be 100. Now, if you do add this up, whatever number you get, it is irrelevant. Right? It has no meaning. Okay, so you do not need to add up, or don't ever add up the columns under the cumulative. Right? It's because these have no actual meaning. All right. Now, so what we have here is a histogram and a table, right? So we have a table, a frequency table, and then we can illustrate it in a histogram. Right? And now with a small amount of data, so if the data size is not too large, we could actually create a graph where we can see the individual number as well. Okay. Now remember we said earlier that every time we summarize data, we typically loses some information. Right? So if we have, if we have this frequency distribution table, and I see that I have two numbers or two observations inside this class, 50 to 59. However, I do not know what these two actual numbers is, right? They could be both be 51, or it could be one be 52 or 55. I have no idea, right? I have to go back to the original data set to take a look. Okay. Now, the stem and leaf plot, however, or the stem and leaf display, right, offers us a different a different way, right, where we could see the distribution, we could see the shape of the distribution, and we can also see the actual data set. Okay. Now this is only doable with a relatively small set, right, small set, and as we will see in a moment, that as the sample size gets bigger, right, then this becomes much harder to do. The basic idea of the stem and leaf display is very simple. Right? Right. I have these are 3-digit numbers, so I'm simply gonna use the tenth, right? The tenth position as my class, right? And then the ones, right? The ones are my leaves. So here are my stems, right? And then the ones are my leaves. Okay, and this is essentially a histogram, right? But instead of us creating the number of classes, right, and then doing all that work, right, we're just gonna use the 10 for the tens for my class, and then we're gonna call them stems. All right, so looking at the same data set, my minimum is 52. It's going up to 109. Right, so my tens will be the 50s, 60s, 70s, 80, 90, and 10. So I have 6 classes, right? And then so I'll go now. So unfortunately, this is not in order, so we just have to hunt around a little bit. But we'll start by looking for the smallest number. So for example, 52. Okay, for 52. We will do 52. And now with a stem and leaf plot, the way you write is going to be really important, right? You want to write in the same distance. So it doesn't matter if it's a 1 or 2 or 8, right? Even though these numbers have different sizes, but you want to make sure you have the equal space because the shape really matters, right? So for example, right, I have 97. Okay, so 97, then I'll do 9 and then 7. Okay, 97, and so what we can see here then is like there are 3 97s in the data set. Okay, and so if you just follow along each of these numbers, you write them, and you want to write them in order. And what happens then is when you're done, you'll have a graph that goes in ascending order. And if you flip it across, like if you flip your page over, now I have a shape. I have a shape of a histogram. I can see I have a graphical distribution of how how the data is distributed. Okay. Now you can be creative. You can do the stem a couple different ways. So for example, here, if I want to create more classes, I can break each stem in half. Right. So now the stems are still the tens, but everything below 55 will be in the first stem, and everything above 55, right, will be in the second stem. Okay. And then obviously, if you do that, you will get a flatter. You will get a flatter curve, or sorry, a flatter graph, right? If you look across, if you look over here, all right? Now, okay, let's do an example. I think it'll become clear. So I have, I have a data set for mile per gallon. I want to create a stem and leaf plot. Okay. Now, whenever you're creating a stem and leaf plot, you decide what unit you want the stem to be, and you decide what unit you want the leaves to be. Now, most of these is going to be pretty obvious, right? I have 2-digit numbers starting from 15, so the tens, right, all the way to the 40s. Okay, so then I'm just going to do my stem. It's going to be the tens. That's going to be my stem. And then my leaf, I draw a line here, and then my leaf, I will do it once. Okay. Okay. So write down your stem first. My data set goes from tens, tens all the way to 40s. So here we go. Here are my stems. 1, 2. Now, here's the tricky part. I don't have any 30s here. But however, stem and leaf plot is supposed to illustrate the distribution. So the fact that you don't have 30s, that is an important piece of information, and you don't want to omit that. So we're going to go ahead and put a 3 there as well. Okay, and then a 4. Okay, now, and thankfully, this is in ascending order, so I can just read across. Here we go. 15, 16, 18, 19. So 5, 6, 8, and 9. Right? And so now right away you can see that if I look at this table, I know that there's 15, 16, there's 4 numbers, and I know exactly what numbers they are. Okay, 20, and just get in the habit of crossing them out. 20, I have 2 20s, so I'm gonna go ahead and put 0 and 0. Spacing matters because you want, right, each number to you want each column or row here, right, to extend out as many numbers as they are. 21, 21, 21, 1, 1, 1, 22, 24, so 2, 4, 22, 24, and 27, 2, 4, 7. Okay, now there are no 30s. Okay, so we don't put anything there. Just completely leave those leaves. There are no leaves in that stem. And then the last number is 48. And voila. And that's it. All right. And now if we look at it, so now we can see, right? So we can flip it over and you can see it's very quickly, we can see that, oh, this is skewed, right? There's most of the automobiles get around 20 miles a gallon, the 20s, right? And then there's nothing in the 30, and there are outliers here. Maybe this is a Prius or something, right? 48. Okay. All right. Okay. Let's do 2 more examples. 2 more examples below here. All right. Okay. Now with decimal, so let's look at this here, right? With decimal, let's find a proper leaf, like proper leaf unit and the proper stem and a proper stem unit. Okay. So since I'm looking at from my starting point is 8, the largest number is in the 11th. Okay. Then my stem could just be the ones. Okay. All right. So my stem will just be the ones. This is my stem. All right. And then my leaf then will be the 10th, the first decimal place. Right? We call that the 10th. All right. Okay. And we're starting here, so there'll be 8, 9, 10, 11. Okay. And then I go to the 10th. Now, once I write that this is the 10th, I don't need to write it. I don't need to put a decimal. Okay. So here we go. 6, 8, 8. Okay. 9, 1 and 4. Then 10. There's 2, 11, 0 and 7. Okay. 7. No decimal point needed. Okay. All right. Now, this one looks a little trickier. Okay, I want you to think about what data set, or sorry, what is the unit for the leaf and the stem that you would choose. So think about it for 1 second. All right, now your first logical choice might be say, well, I'm gonna use the 6, or sorry, I'm going to use the ones as my leaf, and then the 100 as my or sorry, the tens, right, as my stem, right? That might be your first natural reaction. Now, let me go ahead and draw a line here. I want to illustrate what happens when you do that. Okay, so basically that will be a bad idea. Okay, but here, just see here. So if let's suppose I chose that, right? I want my ones to be my leaf. Okay, then, all right, then. So my first stem is going to start with the lowest number. So here my stems will be starting with a 10. My lowest number here is 168, right, or 1682. So 1068. So if I count that as the 10th, those will be 168. Now once I set that in, how do I write the rest of my stem? I need to go, okay, well, next one will be 167, 168. Oh, sorry, 168, 169, 170, excuse me, 170, 171, all right, and so on. Now, how far do I go? Well, I have to go to the largest number, and the largest number here is going to be 1910. So I have to go all the way down to 191. All right, now that is a lot of stems, but furthermore, it's a lot of blank. It's a lot of blank spaces. All right, that's not very efficient. It's not going to be too informative of a graph. It won't be wrong, but it just simply will not be that informative. Okay, so now here we have to make some compromise. So instead, right, let's go ahead, when you see something like this, let's go ahead and make the stem in the hundreds. Okay, now if the stems are in the hundreds, what is the unit of the leaf then? The unit of the leaf then will be the tenths. Okay, so here we go. Now if I'm going to start at the hundreds, then it's the 16. So I start at the 1600s, and then I go to the 1700s, the 1800s, and the 1900s. Okay, and that's it. I have 4 stems, 4 classes. Okay, now then if I have the 16, so now then I'm going to basically ignore the ones. Okay, so in the 1600s I have a 16.8. So I have a 1680s, okay, and then cross that out. Okay, oh, and that's it. Now the 1700s, I have a 1717, so that is a 1. Now you can write that as a 2. We can go ahead and round up. Go ahead and round. That's going to be 2, right? Right, and then 17.9. Okay, so that would be a 9 there. Okay, cross that out. Okay, in the 18s, we'll have now this we can round up to a 1. Okay. And then a 4. And by the way, it's not that rigorous that how you round, like how you actually round. Like just as long as you make it clear. And the ultimate goal is to get the graphical representation of the distribution anyway, right? So you should get a 1 there and a 7 here. Okay, and here now, so we lose some information because now we don't have any information on what is the 1 digit or the ones digit for each of these numbers, but we still get a shape. We can still get a shape of the distribution, right? If you flip it over, we can still see how the graph is distributed. Okay, and that's it.